All right, Algebra 1, we are going to finish up this long chapter 5 here. It's been all about lines and doing everything with lines. And then we take kind of an odd, strange trip here to deal with graphing an absolute value function. They are going to be V shapes, right? So if we have y equals the absolute value of x, right? So this would be the origin right there. So we're looking at these V shapes, but we're going to focus mostly on translations. I'm not going to have you make tables or do anything else. So we just have to understand that this is the new shape that we're going to deal with, this V shape right here. And we may turn them upside down as well. That's basically it. Okay, so translation is when we take the graph and we shift it horizontally, all right, left and right, vertically, or both. But it should be the same size, the same shape, it's just located in a different spot. So it's kind of like, if you had your favorite house and you didn't want to leave it, but you wanted to leave the area, you just picked up the house and moved it somewhere else and put it back down. That's basically what you'd have. Your room's still the same place, just a whole different GPS location. All right, so here's what we have. If we're going to take these lines or these absolute values, so here we have the parent, the original one. This was going to be -2. And I kind of jumped over the thing from the beginning here, but notice up here in line 1, this was y equals, what do we got? 1, 1, 2, 3, 1/3 x plus 1, and y equals 1/3 x minus 1. So the only difference here is the plus and minus 1, but notice what happened to the graph. As the blue one moved down 1, the red one moved up 1. So that's what you see here. Sorry, that was a little bit of a tangent. So this -2 takes us down 2, but then we're going to stick that V shape on there. How do I know how wide to make it? Well, right now it's 1x squared, so it's going to go up 1 over 1 just like slope. So we'll run it just like that. Primarily, I'm looking for the location of that vertex point, right, where we start the whole thing, and then the orientation, whether it opens up or opens down. Okay, so what would happen if it said +2? What would you do? Well, I'd create myself an x and y axis. I would go 1, 2, +2. I'd say that's the vertex, and then I'd go up 1 over 1 and get my shape just like that. He's saying, good question. Hey, Mr. Tola, what if it was negative? Okay, so if it was negative, all I would do is take this V shape and make it go down 1, just like slope, right? Down 1 over 1. So I would get this shape here if I threw the negative on there. Okay, why does that make a difference? It only makes a difference when we start talking about the next thing, which is the domain. Okay, so remember that's your x values, and this absolute value is going to go left and right forever, so it's all real numbers. Remember, our symbol for that is that capital R mixed with a paragraph sign. Okay, and we're going to use just this orange one, the original one here, to talk about the range as well. So it's talking about the y values. And notice it's going to start here and it only goes up. So it's going to be greater than or equal to 2. Okay, so we can start getting domain and range questions here, but domain's going to be pretty simple for the absolute value because it's always going to be all real numbers. So at some point I may stop asking that or requiring that because it's always the same thing. It's the range. It's going to be greater than because it opens up. If I use this -1, right, if I use the -1, it would be less than or equal to 2 because it started there and went down. So that's kind of the big thing. Here's what we got. How is this graph to the right related to the graph of, right? So this is just the parent, right? So what I'm going to do here is go, okay, so that's 2. That must be 3. Okay, 1, 2, 3, 4. Okay, so it must be up 4. So what's that make the function look like? Y equals absolute value of x. How do I move it up 4? I go +4. That's exactly how I do it. What's the domain and range of each function in problem 1? Okay, so in problem 1, okay, so let's do this. Y equals absolute value of x. The domain, all reals. Y equals absolute value of x plus 4. Domain, all reals, right? That's going to be the same thing. What about the range? The range, well, they both are going to open up. So with the original one, remember that would start at 0, 0 and go up. So it's greater than or equal to 0. But here the range is y is greater than or equal to. Remember this value was 4 because of +4. All right, so that's going to show us how they are related and what's happening there. So if we move it up 4, it changes the range. All right, now this one might be a little bit confusing because it seems a little bit backwards. Okay, so here we have x plus 2, And notice what happens is it ends up going to -2. Okay, so what we're going to say is if it's inside the absolute value, you're going to think about going opposite of what you see. Why does it happen? It happens because of this. If you actually solve it, we get x equals -2. Okay, so that gives us a location on where it should start. So to get to +2, I'm going to have to use x minus 2 in this one to get there. What would happen if you solved it? You'd get +2. So what you're going to think about all the time is if I'm looking at something inside the absolute value, it's left and right, and it's always going to be opposite of what you see. Okay? So having said that, if we look at this one, it says x plus 5. So if it says plus 5, I'm thinking 1, 2, 3, 4, 5, -5. There's nothing added on after it, right? It's plus 0, so it doesn't move up or down, but it is positive, so it's going to open up. What about the domain? All real numbers. Same thing again. And the range, y is greater than 2. Well, it's going to be 0 again, right? Because it didn't move up or down. It only moved left and right. So we're going to have both of those for that to happen. Let's make sure you got that idea. If I want to go to the right 9 units, y equals x something 9. Right is typically to the right is positive, so I have to use negative. If I want to go left 4 units, y equals absolute value of x. I'm going to have to put 4 on the inside because it says left or right. Left, I think of negative, so I'm going to put in plus because they're always going to be opposite on the inside. All right, here's 2 more. Make sure we have it. To the right 8 units. So that means we're going to put the 8 inside the absolute value. I want to get to the right, which is positive. I have to put in negative. And x with 6. If I want to get to the left, which is negative, I have to put in positive. All right, they did ask for an equation, so don't forget to squeeze that y equals in there as well. And that's how we handle those. All right, so remember outside is up and down. So this one is down 8. Inside, that's going to be left and right, and it's opposite of what you see. So this should be left 7. So it takes care of some of those. All right, just as a quick review, you probably do want to do the standardized test prep. I'll be looking for that in your notebook, and it goes into our graphing. These are all in slope-intercept form, so we're working with that intercept and then moving up or down from there. All right, so give those a try, and we will touch base on these in class.